Okay, good afternoon. Welcome back. It's Thursday, April 2nd. Another lesson on algebra for you today. We're just going to do a series of problems in multiplication and talk about, traps, easy pitfalls, things that it's easy for me to forget, it's easy I've seen students forget, and things you just want to get used to doing very, very well and consistently. So let's just start with a nice, easy example here. A polynomial, a line, times this polynomial. It's in two variables, but that's okay. It's going to help us understand, what multiplication looks like and how we can combine. Now, the first thing that we always want to remember here is that when we have sets of parentheses that are lined up with each other here, like these two, with nothing in between, that is an implied multiplication, okay? So two parentheses, a close and an open parentheses backed up to each other like that implies multiplication here. The other thing we want to remember is if we can simplify inside the parentheses, we should, meaning we should look at these sets of parentheses a little bit separately first. So I'll do that. X minus 4, nothing to do there, can't combine. Those are different degree terms. 3x minus y plus 3. Okay, so 3x and minus y, you might be arguing those are both degree 1 terms, but they're different variables. Therefore, they also cannot combine. Now, as an aside, that doesn't mean anything with x's and y's can't combine. If, for instance, it was 3xy plus xy, those could combine because they are similar terms to 4xy. They are so-called like terms. Okay, so back to this problem here. Can't do anything inside either set of parentheses. So inside the parentheses, already simplified as far as I can go. So it's time to actually execute this multiplication here. In order to do that, I need to be very careful here and make sure that I distribute, right? We did a couple on Tuesday that you can go back and look at if you'd like. But distribution here for me, I'm going to multiply this x by all three of the terms in this second set of parentheses. By all three, I'm going to be very careful. 1x times 3x, that's 3x squared. 1x times minus 1y is negative xy. 1x times positive 3 is plus 3x. Okay, so hopefully you can see where all of those are coming from. This is like this. Those are multiplying together. This term is these two. This third term is these two, right? Now I'll do the same thing, and be careful here. Got to do the same thing with the secondary term. Essentially, you need each term here to multiply by everything else in the second set of parentheses. So we just did x, now we need to do negative 4. Can't forget about the minus sign there. Negative 4. And the negative affects every internal multiplication that we're doing here. So it is negative 4 times 3x, that's negative 12x. It is negative 4 times negative y, those negatives ones multiply to positive 1, and negative 4 times positive 3. Okay. And a nice equal sign. Remember, that's what we're doing. We are able to, when we're simplifying or when we're executing any operations, we are establishing an equal sign. We are meant to write an equivalent expression. Not the same exact thing. We are writing an equivalent expression, meaning that if we plugged in x's and y's to either the top line or the second line here, they would give us the same result. And we're going to continue to do that, right? Once we have executed a multiplication that gets rid of parentheses, we'll also execute any additions or subtractions that we can do. So the process here is a bit tedious. You just want to be careful for yourself. You just look at each term, right? So right now on this line here, there are 6 terms. There's a 3x squared, a minus xy, a plus 3x, a minus 12x, a plus 4y, and a minus 12. And what we're really looking at is the powers of x's and y's. Do they ever match between any of those 6 terms? And in fact, they do, but only once, right here. Both of those terms just have x to the first and y to the 0. So those two will combine. All the other ones are unique in this set of 6 terms. So 3x squared is just coming along. It doesn't combine with anything. Minus xy is also coming along. Doesn't combine with anything. The 3x and minus 12x do combine to minus 9x. Plus 4y doesn't combine with anything. And the minus 12 doesn't combine with anything. And therefore, we've executed all of the multiplications, additions, subtractions. There are no divisions in this case that are relevant. We've done all that we can. So we would say, in general, that this one is, in fact, simplified. Okay. And look at these equal signs, right? So each of these 3 lines, 1, 2, 3, those are equivalent. If we plugged in the same value of x and y to each of them, they would get the same number out every time. Okay. Let's do another one. All right. So remember our first step here. It's a tool that we always want to keep in mind. If we see parentheses, can we simplify within the parentheses? If we can, great. If we can't, that's fine. It's fine. So we don't want to like overdo it in the sense of like attempting to do things that we cannot actually do, or things that don't establish a equivalent expression inside the parentheses. So like these 2 terms can't combine, right? One is in terms of x and one is in terms of y. So I think each set of parentheses, I'm looking at it, 3x minus 4y, nothing to do there. Negative 2x plus 5y minus 6, nothing to do there. So I'm going to execute the implied multiplication between the sets of parentheses. And I'll start by multiplying 3x, the first term in the first set of parentheses, by each of the terms in the second set. So 3x times negative 2x, that's negative 6x squared. 3x times 5y, that's 15x times y. 3x times negative 6, that's negative 18x. Okay, not done. We have to execute the entire multiplication here. It's 2 sets of distributions. We've distributed 3x multiplied by the second set of parentheses, the terms in there. Now we'll do negative 4y. So negative 4y times negative 2x positive 8xy. Negative 4y times positive 5y, negative 20y squared. Negative 4y times negative 6 plus 24y. So again, the equal sign here, we're establishing it. We are doing things that we know, such as multiplication. If we execute the multiplication properly, it will give us something that looks different, but acts the same. Meaning if we plugged in x equal 1 and y equals 3 here, and then did the same thing here, calculated it all out, would give us the same number. Okay. If we did that for any set of x and y that are allowable here, that will work. Now let's do the same thing, but now instead of executing a multiplication, let's do an addition if we can. X squared term won't combine with anything. XY term, yeah, I see two of them. So negative 6x squared is just coming along, doesn't get to combine with anything. The xy term does. There are 23 of them. Nothing to match the x term, nothing to match the y squared term, nothing to match the y term, and that's it. That's it. So, you know, the problem themselves, they look a little gnarly, they look a little complicated, there's a lot of terms, a lot of things to keep track of. Just deep breath, step through, simplify inside the parentheses. Okay, can't do that. If I could, I would. Do the multiplication, first the equal sign, do distribution one pair of terms at a time, step through, then combine when you can. Okay, do one more and then we'll erase here. Yeah, that's a good one. Let's do 2y minus 1 times 2y plus 1 times 4y squared plus 1. All right. Just clean this up a little bit, make sure that everyone knows what's going on. Those are two sets of parentheses. So here's an example. We're asked to simplify this or multiply it out. All right, can we simplify inside? Now we have three pairs of parentheses. 2y minus 1, 2y plus 1, 4y squared plus 1. Can we simplify inside of any of these? And the answer there is no. 2y minus 1 as simple as it gets, 2y plus 1 as simple as it can get, 4y squared plus 1 as simple as it can get. So we execute multiplications. And here, just another layering. This is going to be very, very, very common for algebra. Just layer the complications onto each other, but the spirit of what we're doing is the same. We are trying to execute operations, addition, subtraction, multiplication, and division properly so that we can get this into a simple version where maybe we're looking at just a single polynomial in terms of y as opposed to three separate polynomials multiplied together. Okay. And as is often the case, when we layer things, the simple reaction to that is to take it one piece at a time. So now we have two implied multiplications between sets of parentheses here and here. Do one of those implied multiplications and then worry about the next one. So like to go left to right. It's very, very common here. Notice you can do the second two first if you'd like, but left to right is a nice strategy to just be thinking about. So 2y minus 1 times 2y plus 1. I'm going to even make this clear that I'm just bringing this down. I'm not going to deal with that multiplication just yet. And so I'm actually going to have a result here from 2y minus 1 times 2y plus 1 that I'm going to put inside of parentheses to recognize that this multiplication has not taken place. It still needs to take place. So 2y minus 1 times 2y plus 1. Okay, 2y times 2y, that's 4y squared. 2y times 1, that's plus 2y. Negative 1 times 2y minus 2y. Negative 1 times positive 1 minus 1. Okay. Now again, we want to keep the spirit of what we're doing in our minds here. So yes, you can execute the multiplication right away. But what is our first step before doing parenthesis multiplication? To look inside both of those sets of parentheses and see if we can simplify. And here, of course, 4y squared plus 1 is still there. And we said it was already simplified, and it still remains already simplified. But after executing this multiplication, we actually do get something that simplifies over here. We get 4y squared minus 1. The positive 2y minus 2y is 0. Just clear this up. So that's a y, and that's a minus 1. And interestingly enough, we could have done the multiplication. We'd have 8 terms, and then simplify. But if we simplify within the parentheses first, you can see now this multiplication will go much quicker, and it will only have 4 terms. So 4y squared times 4y squared, 16y to the 4th. 4y squared times 1, so plus 4y squared. Negative 1 times 4y squared, so negative 4y squared. And negative 1 times positive 1, so minus 1. So we've executed all of the multiplications that help us get rid of parentheses to look at a simplified version perhaps. And now, again, our question is, can we combine like terms? Yes, we can. The middle 2 terms there actually combine to 0. 4y squared minus 4y squared. So it's questions like these that are really nice for recognizing kind of the power of what simplification is trying to do. Now, it's not the only thing we try to do, and in fact, in next week's lessons, we'll likely look at something that takes us in the reverse direction, in fact, which is called factoring. So we might actually see this thing factors to this first line, and that's useful for different reasons. It simplifies parts of it. It's not the simplified polynomial, but does do certain things for us. For example, the top line helps us really understand what values of y we can plug in to make the overall thing 0, because we know 0 times anything is always 0. So I'll look ahead to what we're trying to do. But for simplification here, this direction, very useful, as you can tell. Instead of 3 polynomials multiplied together, 1 single polynomial of degree 4. They are equivalent. Plug in any y you want in the top, any y you want in the bottom, the very bottom, or any of them actually, but the very bottom, get the same value out. I'll give you an example. Let y be 1 up here at the blue star. Let y be 1, so 2 times 1 minus 1, that's 1. 2 times 1 plus 1, that's 3, so 1 times 3. 4y squared plus 1, that's 5, so 1 times 3 times 5, that's 15. The bottom, let y be 1. Y to the 4th is 1. 1 to the 4th is 1, I mean. 16 times 1 is 16, minus 1 is 15, so they're 15 in both cases. And that's the point of what we're doing. If that wasn't true, if we were plugging in a y on the top, plugging in the same y on the bottom, and they were not equal, then we have not simplified. We do not have equivalent expressions, and these equal signs at some point would have stopped being true. But seems like we did okay, at least with that first example of y being equal to 1. All right, let's scroll back up. Erase this. Let's see here. Let's do this. 2 plus 5x. Okay. 3 first-degree polynomials multiplied together. So these are 3 lines. They describe different lines. I'm trying to multiply their outputs together to see like maybe how they all interact together via multiplication. Well, we can think about simplifying this. And again, because it's 3, there are 2 implied multiplications, right, between these 2 sets of parentheses or close and open parentheses. And we need to execute them if we can. because that will help us be able to move terms around. Right now, notice that this minus 3x, you can't slide it over here, right, into there. It's not how it works. Because it's an undistributed minus 3x, it actually gets multiplied by a bunch of different things. So it's not free to move around because it hasn't done the multiplication. After the multiplication, it is free to move around. It can get, the parentheses are gone, it can move. So let's do that and see, what happens. In fact, what we're doing is saying that when we're talking about moving around the minus 3x, that's not what we're talking about moving around at all, because we need to multiply it out. So let's see here. I'm going to start from the left. I'm going to do those two sets of parentheses first, so this will come along. 2 times 11, 22, plus 2 times 2x, 4x. 5x times 11 plus 55x. 5x times 2x plus 10x squared. Okay. I don't usually write the 1 minus 3x right away. I'll wait so that my spacing is good, but just to illustrate what we're doing. So now I'm going to look at this and say, okay, it's another multiplication I want to do, but it looks like this left set of parentheses here does have a simplification to do. So I'm going to go ahead and do it. Add those two x terms together. Make things a bit easier. Instead of 4 terms times 2 terms, it's just 3 terms times 2 terms. Okay, let's see if I can do this in my head here. 22 times 1 is 22. 22 times negative 3x is negative 66x. 59x times 1 is 59x. 59x times negative 3 is minus, I think, 177x squared. And if I've done that wrong, I apologize. I think that's right. 10x squared times 1 is 10x squared. 10x squared times negative 3x is negative 30x cubed. So each of these equal signs we have executed either a multiplication or a simplification, like an addition or subtraction, or another multiplication. And our goal now is we've eliminated the parentheses, right? And this is where, we're not actually, when we're talking about like dealing with, say, what happens to that negative 3x, it's not actually a negative 3x at all. It's embedded in several terms. It's multiplied out, right? So now we're in terms that are multiplied out and can move. They are not restricted by parentheses because they've been multiplied out. We have done the distribution. And so let's see. The 22 doesn't have a partner. The negative 66x, positive 59x get to combine, negative 7x. The negative 177 x squared and 10x squared also combine, negative 167x squared, and the negative 30x cubed is stuck. No partner. So that top line is this bottom line, and that's simplified. As an aside, you might see also a really simple form, a really basic form of simplification, reordering. It's very common. It's called the general form of polynomials, to see the highest degree terms go left to right and decrease. So it's a reordering there. No combination left to do, but a nice reordering. Okay. Now one last problem then. Let's erase this. Thanks again for watching. Whenever you do get a chance, make sure you're keeping up with all of your work, what your teachers and coordinators are asking you to do, and make sure to post comments on these videos if you have questions. I'd be happy to address them in a future session so you could see that. Last problem, more of the same. Just giving you a final opportunity today to do something with just multiplication and no division. We'll look at division on Tuesday. So we're going to multiply this out. Now, this is an interesting question because I said left to right. Okay. You don't always have to do left to right if you don't want to. And in some cases, it may actually be useful not to. You could do 2x minus 3 times 2x plus 3 times 2x minus 3 first if you'd like to. But I'm going to continue with the left to right. So if you decide to try that, see if at the end of it all, you get the same simplified version that I do. So I'm going to multiply 3x minus 2 times 2x plus 3. 6x squared. Notice I know to write a parenthesis there because I know this I'm not dealing with until the next line. So I need another multiplication. I will need to close this off and multiply it through in the next step. So 3x times 2x is 6x squared. 3x times 3 is 9x. Minus 2 times 2x is, minus 4x. And minus 2 times 3 is minus 6. I'm going to simplify inside the parentheses anytime that I can do that to make the multiplication between sets of parentheses easier and have fewer terms. Okay. 6x squared times 2x, 12x cubed. 6x squared times negative 3 minus 18x squared. 5x times 2x plus 10x squared. 5x times negative 3 minus 15x. Negative 6 times 2x, negative 12x. Negative 6 times negative 3, positive 18. And last but not least, let me combine like terms. I see two terms with x squareds. I see two terms with x's. And then I see standalone terms here. Right there. So 12x cubed minus 8x squared minus 27x plus 18. Done. Nothing else to do to simplify that. So you can see the layering, right? First, we learned some tools for simplifying. Then we apply those tools to more and more complicated problems where we can multiply, where we have some multiple multiplications, right? We do 2 or 3 or 4 multiplications together, and this would go on indefinitely. If we just added another set of parentheses here, we could do that and do this multiplication and do this simplification. Of course, it makes it more and more complicated. It has more and more terms. But as long as you keep in mind the tools you have and take it one step at a time, don't try to do too much at once, you should be all right. So I look forward to next week for the algebra group. If you're interested in stats or need geometry, remember to look at Wednesday's episodes and tomorrow's episode, which is stats. And until then,